Calculus, Chapter 1, Section 3, Average Rates of Change. If you drive 110 miles in 2 hours, then your average rate of change, or your average speed, is 55 miles per hour. And we get that by doing 110, your distance, divided by 2 hours, your time. However, it doesn't mean you are driving exactly 55 miles per hour during every second of your drive. The exact speed you're going at any given moment of time during the drive is what is called your instantaneous rate of change. And we can use limits in calculus to find instantaneous rates of change. And first, we're going to look at average rates of change. We're going to start with some simple examples. So you should be able to do this. Try this on your own. Pause the recording, do this example, and resume to check your answer. Okay, at 9 a.m. there had been 20 suits produced, and at 10 a.m. 55. So between 9 and 10, 55 minus 20 gives you 35 suits. And they're saying, notice that now the red is the curve that's the actual production. And they've got the blue lines that are kind of drawn in between the different points. So the solution to the problem is 35. It also happens to be the slope between the 2 points, the straight line drawn between the 2 points P and Q. Now try this question. What was the average number of suits produced from 9 to 11 per hour? Pause the recording, give this a try, and resume to check your answer. Okay, so we have 64 suits that were produced by 11 and 20 that were produced by 9, so 64 minus 20 gives us 44. Those were done between 11 and 9, so that's 2-hour time, 22 suits per hour. And notice that 22 would be the slope. If you were to draw a line between P and R, 22 would be the slope of that line. It's the y value minus the y value over the x value minus the x value. The rate of change of y with respect to x as x changes from x1 to x2 is the ratio of the change in output to the change in input. Or in other words, it's the slope. If you want to know what the average rate of change is between two particular points on a function, then you find the slope of the line that would join the 2 points. Now, if we look at the graph of this function, we see that y2 minus y1 over x2 minus x1 is the same. The y values are the function values at those particular x's. So y2 is f of x2, y1 is f of x1. Okay, and that's both the average rate of change and the slope of the line from P to Q. The line through P and Q, the line PQ, is called a secant line. Okay, now try this example. For y equals f of x equals x squared, find the rate of change as x changes from 1 to 3, from 1 to 2, and from 2 to 3. Let me give you a hint. You're going to need to find the y value or the f of x value for each of these x values. Pause the recording, give this a try, and resume to check your answer. So when x1 is 1, then y is 1. When x is 3, y is 9. So the rate of change is going to be 9 minus 1 over 3 minus 1. It's 8 over 2, which is 4. Okay, we already figured out that when x is 1, y is 1. When x is 2, y is 4. So my average rate of change is going to be 4 minus 1 over 2 minus 1, which is 3. And then finally, when x is 2, y is 4. And when x is 3, y is 9. And my average rate of change is 9 minus 4 over 3 minus 2, which is 5 over 1, or 5. To come up with a general definition for average rate of change, we need 2 points, and those 2 points are x1, f of x1, and x2, f of x2. But we really want to be able to eliminate the subscripts. So what we're going to do is, instead of x2, we're going to think of x2 as being x1 moved h units away. So x1 will be just x, and x2 will be x plus h. Now that's going to change our y values also. So we're going to have f of x in place of f of x1, and we're going to have f of x plus h in place of f of x2. So what we're going to do is we're going to take those 2 points that we now have, x, f of x, and x plus h, f of x plus h, and we're going to put them into the slope formula as you see below. Now, the numerator, you really can't do anything with it unless you know what the function is, and we don't. It's just a general definition. But notice in the denominator that I have x plus h minus x, which means that the two x's are going to cancel each other. X minus x is 0, and just leaves me with h in the denominator. That leads us to this definition. The average rate of change of f with respect to x is called the difference quotient, and it is given by f of x plus h minus f of x over h. The difference quotient is equal to the slope of the secant line from x, f of x, to x plus h, f of x plus h. So really what this is, it's a simplified form of the slope. H is the distance that you're moving from one x value to the next. All right, try this using the difference quotient. Put them into the formula, give it your best shot, pause the recording to do that, and resume to check your answer. Okay, so we're going to put in 5 for x and h for 3. So we get f of x plus h minus f of x equals f of x plus 3 minus f of 5 over 3. And let's see, our function is x squared. So we're going to do f of 8 minus f of 5 over 3, which is going to be 8 squared minus 5 squared over 3. 64 minus 25 over 3 gives us 39 over 3, or 13. We're going to put in 5 for x and 0.1 for h. And we're going to square them because that's our formula is f of x equals x squared. And we get 26.01 minus 25 over 0.1. 1.01 over 0.1, and that gives us 10.1. Okay, let's try another example. Now this time what we're going to do is we're going to very simply put this function into the difference quotient. We don't have values for h, we don't have a value for x, but we're going to put this in, and we're going to see if we can simplify anything. Pause the recording, give it a try, and resume to check your answer. Okay, so f of x plus h would be x plus h to the third. Now this is the hard part. You do have to cube it, and that gives us x cubed plus 3x squared h plus 3xh squared plus h to the third. There is a formula for cubing something, or you can FOIL it out. You just do x plus h times x plus h and multiply that, whatever you get, by x plus h. So we have x plus h to the third. So we're going to have that whole long thing minus f of x, which is just x cubed. And what they did is they simplified that first. So that gave us the x cubes go away, and that gives us 3x squared h plus 3x h squared plus h to the third. And then we put that over h. And then notice that we can factor an h out of the top, so we do that. And then the top and bottom h's will cancel, and that leaves us with 3x squared plus 3xh plus h squared. Of what we just talked about. So read over it, pause the recording to give yourself time, and then resume to move on to some additional examples. Okay, these are some practice problems. Pause the recording to do them, and then resume to check your answer and continue in this way through the rest of the recording.